Welcome everyone to the series of sorting and searching. In this video, I am going to discuss about merge sort. Now, merge sort is actually a divide and conquer technique where the array is actually first divided into two smaller sublists, and this process gets repeatedly till only one element is left in the sublist. That is, initially the array will be divided into two sublists, then each of the sublists will again be divided into two sublists, and so on until there is only one element in the sublist. And then again we are going to merge this each sublist so that in a sorted pattern until we get the original sorted list. So let us understand it with the help of an example. Consider an array of 7 elements indexed from 0 to 6. So the elements, as you can see, they are in a unsorted manner. Now as the merge sort says that we are going to divide them into two sublists initially. So 7 elements, let's say approximate, because you cannot get exactly every time even number of elements in the array. So an approximate measure you are going to take, and you will divide the sublist into two parts, that is one containing 3 elements and the another containing 4 elements. Thereafter, again in the second iteration, we are going to divide each of the sublist. Let's consider the left sublist and we divide it again into two parts. That is one a sublist having only one element 12 and another one having two elements 8 and 9. Thereafter, we are going to divide 8 and 9, the sublist having two elements 8 and 9, into two separate sublists. Now we go to the upper right sublist where there were 4 elements. It will be broken down into two sublists, each containing 2 elements. Thereafter, the first sublist in this series will be divided into two parts until there are only one element in each list, and so on for the next one. So now the situation is that we have got each element is one sublist. Now we will go on merging this sublist, but that will be done in a sorted order. Means when you are going to add one element to a sublist, you are going to put them in a sorted order. So first consider 8 and 9, each is one sublist. So we are going 8 is smaller than 9. So the upper list merged list, that is why we are calling it as a merge sort. So we are merging the sublist. So while merging, we are going to sort it. So since 8 is smaller than 9, 8 will come before 9. Thereafter, we will consider another sublist, that is 12. And since 12 is greater than both 8 and 9, it will be added at the second position if the index starts from the 0th position. Now let's consider the other elements. The other elements were 3 and 11. So 3 and 11 will be merged to form two array sublist, and another sublist were 5 and 4. So since 4 is smaller than 5, we are going to add it like 4 and 5. Now we have to merge these two sublists, that is 3, 11 and 4, 5. So we are going to compare each element with one another. So since 3 is the smallest one, it will be the first element in this sublist, and 11 is the greatest among all. So it will be the last element in this sublist. Thereafter, we are going to merge these two sublists initially, which we had broken down. So this will come out to be your 3, 8, 9 and 12, because we are first considering only, we are picking up one element, that is 12, and we are merging with it. Now you merge along with 4, 5 and 11, right? So now if you merge here, so I picked up only one element 3. Okay, and I tried to merge it with 8, 9 and 12. So 3 came in the beginning. Next I want to merge with 4, 5 and 11. So I will just pick up 4 in the similar way. So 4 will be added after 3. So 3, 4, 8, 9, 12. Next I will check it with 5. So 5 will come after 3 and 4. And then I am going to merge 11 with it. So I get the original size array. But now this time the elements are in a sorted order. Now, regarding the time complexity of merge sort, now the concept of time complexity and how do we calculate the time complexity has already been discussed in my earlier video in this series. Please go through the video to understand about what is a logarithmic time. So here we are saying it is the time complexity comes out to be n into log 2 to log n to the base 2. Now, why it is so? Because when you are going to, when we are dividing the elements in sublist, so that time, the time complexity reduces to half in each iteration, right? So the upper list was 7, then it became 3. I am working on only 3 elements, then I am working on only 2 elements, then 1 element. So at every iteration, my values are going to decrease. That is why it is log n to the base 2. But while merging, I have to go through all the elements. So it is a linear time. Okay, because the merging is a linear merging. One elements are being picked in the array and the comparison is done and they are inserted, right? So it is a linear merging. So the total time complexity comes out to be n into log n to the base 2. I hope you understood the concept of merge sort. Now, in my next video, I am going to discuss about a very interesting type of a sort, that is a heap sort. So please stay tuned for more such informative videos and don't forget to like, share and subscribe CSC Core Concepts if you like the channel. Thank you very much.